Hey guys, welcome back to another Math with Max and Rocky. So here's Max being adorably cute and all rolled up as usual. Pretty cold outside, so they've been inside all afternoon, right Maxie? You gonna wake up? Oh, you okay? You okay? How are you? Did you have a good day? Oh, he's like, just let me sleep. Go back to sleep. You can go back to sleep. And then over here, if you can see him, we have my friend Rocky, who is also asleep. He's been asleep. Right, boys? You've been asleep? Yeah. When are these guys not asleep though, right? Like they're always asleep. So, okay. So this video is over coordinate grids or ordered pairs on the coordinate plane, which is what we titled our notes. If you were at school today, when I taught this lesson, you would have these notes. I also sent the notes out on Remind 101, so for those of you who weren't here, you could have written those notes in your journal. If not, you're a little bit behind. I'm sorry that you didn't make it to school on this cold day, but yeah, we can't miss, guys. We only have so many days left until benchmark 2. I think it's like 2 weeks after this week, and I still have several things I need to teach you. So being at school is 100% important every single day, every moment of the day, because you're not just missing my class, you're also missing reading class and science class and social studies and more reading also with Mrs. Rada. So like I said, attendance is so important every single day. That's why I do my best to be there every single day. I take care of myself so that I don't get sick, and yeah, I just do my best. All right, so like I said, this is the coordinate ordered pairs on the plane, also known as ordered pairs on the coordinate grid. It has a lot of names. So before I jump into, well, first you should have two handouts. One that looks like this one. Okay, so if the before I move on, before I even start really, if you have not turned in your homework, you need to do it right now, because tomorrow, sorry, I keep looking at my hair and I feel like it looks weird for some reason. Anyway, on Friday when I come back in, if your homework's not in the basket before I get there, I'm not going to count it, because that means that you did not turn it in on time. So please make sure that's in the basket before you get to school on tonight's homework, which is the oh gosh, I forgot the number. Well, either way, it's over the coordinate grid, and then whatever homework is assigned tonight, Thursday night. The homework that's assigned on the backboard might be different from what I'm about to tell you right now. So whatever the backboard says, just ignore it. Your next homework is the next 2 pages of your daily TEKS. So it's either going to be 6-7 and 6-8 or 7-1 and 7. I want to say it's 6-7 and 6-8, or whatever the next 2 pages are of your daily TEKS. That is your homework tonight. Okay, Thursday night's homework is the next 2 pages of your daily TEKS. So please disregard whatever's on the backboard if it doesn't say daily TEKS, okay? So again, just make sure that those are, that is the homework that you're doing tonight. So both of those homeworks will be due on Friday when I see you. All right, so again, you should have this pink one right here, and then you should have another pink one that has 4 questions on this side, and then 4 questions on that side. All right, so, yeah, I want to start with this one. So this one says, it doesn't really have a title, but right here, if you can see it, it does say, I can't read backwards. It says, graph each point correctly on the grid and label them with the correct letter. Remember the rules. Okay, so for those of you, I'm just going to do a little recap for those that were not at school on Wednesday. The rule for this type of assignment is that you want to go in the elevator and then up the elevator. So when we're going in the elevator, we want to go to the right on the x-axis, and then when we're going up the elevator, we want to go up on the y-axis. Okay, so what do I mean by axis? Okay, we have 2 axes. The first one is the x-axis, and that is a horizontal line. Horizontal means that you're going from left to right. So going from left to right, this is a horizontal line. So if you hear me say, which one is the horizontal line? I mean the line that is moving from left to right. And yes, you do need to know what horizontal means, okay? So again, horizontal is left to right. That's what that axis is. And then you also have your y-axis, and that y-axis is also called a vertical line. A vertical line goes up and down, okay? Horizontal goes left to right, and vertical goes up and down. So that is another word that you do need to know, horizontal and vertical. So horizontal, vertical, okay? And these two axes, your x and your y-axis, do cross each other. They make perpendicular lines. And we talked about perpendicular, I want to say last week, because there was a question on your Daily Teaks homework that was asking you to make a perpendicular line. Draw one line straight down, and all of you were like, oh, that's what I should have done. Yes, that's what you should have done. You should have drawn a line straight down to represent a perpendicular line. Perpendicular lines are two lines that do cross each other and will make perfect 90-degree angles or L's. Okay? And don't get that confused with parallel lines. Parallel lines are two lines that will never touch. They can be right up next to each other, but they will never meet. They are never going to touch, not going to happen, okay? So that's parallel lines, and this is perpendicular, okay? Perpendicular makes the 90-degree angles there, okay? So we're talking about quadrant number 1. So we talked about that in our notes, quadrant number 1. There are 4 quadrants. And we are only going to be focused in this quadrant right here because the x-axis and your y-axis, when they cross each other, they do make 4 different spaces. And they meet right here at the origin. That's where they cross at. So the origin is where everything begins. That's going to be our starting point. So origin, that word right there, is this point right here that we're going to be seeing a lot and using a lot. It is always our starting point. That's what origin means, where everything begins. So for us, everything begins at the origin. If we don't start at the origin, our answer is going to come out wrong. Okay, I'm telling you that right now. Don't start at the origin, answer is wrong. If you don't start at the origin, answer is wrong. Okay? Another word we need to know is increment. An increment is the space between numbers. So, oops, I forgot to add something right here. Okay? So again, this blue dot represents my origin. This right here is my x-axis, and then going up and down, that is my y-axis. So if I look at my numbers here, right here would be 0 because that's where my origin is. Origin is always 0, 0. So here we have 3, 6, 9, and 12. So what is the difference between 3 and 6? Well, obviously, that's 3. 3, 6, 9, 12. I'm counting by 3s. So my increment is in 3s. If I was having at the bottom 2, 4, 6, 9, 2, 4, 6, 9, 2, 4, 6, 8, obviously my increments would be 2. If I had 5, 10, 15, 20, my increments would be in 5s. So whatever it is, but the thing is you have to keep it consistent. Every increment has to be the same. You can't do 2 here, and then 3 here, and then 10 here. That's not how it works. All the increments have to be the same. Okay? And I say that because eventually you will have to make your own coordinate grid, and it's important that you understand that those increments have to be equal to each other. So when you are drawing one, you need to make sure that your spaces are somewhat equal to each other as best you can. All right, so that's all your vocabulary. So again, that's increment, the space between two numbers. The origin is where we begin, and the origin again is right here in the center. You're not going to see these quadrants. We're only going to be seeing this first quadrant right here, but that is where the origin is always going to be, in the corner. And the origin, let me write that down just so those of you who weren't here yesterday remember, or know, I should say. The origin, when I say what's the ordered pair for the origin, you're always going to tell me 0, 0. Okay? Origin is 0. Origin starts with an O, so it must be at point 0, 0. And then we also have our y-axis, which runs up and down. And then again, we have our x-axis, which is horizontal and runs left to right. And then our rule is that we always want to start at the origin. I should have included that in the rule. We want to start at the origin, then we want to go in the elevator on the x-axis, and then we want to go up the elevator on the y-axis. Okay, so that's the vocabulary. Got that out of the way. So let's take a look at our paper. Again, we want to graph each point correctly on the grid and label them with the correct letter. Remember the rules. So again, I just said that right now. In the elevator on your x-axis, and then up the elevator on your y-axis. So the very first thing that tells us to do is to label our x-axis. So if you remember our vocabulary, we said our x-axis was going to run from left to right. So if I'm looking at my grid, my x-axis is going to run down this way from left to right on the bottom part. So let me get a pen actually, because I don't want to use a marker. It's going to be too. Is this a pen? Yes. Okay. So right here on my paper, I should have labeled that this line right here was my x-axis. And if it helps, you can do a little arrow to just kind of remember, because that's how we did it in our journal. For those of us who were at school, we did a little arrow just to show that that line was man, why can't I talk today? To show that that line is going to continue on for forever and ever and ever. Infinity. These lines continue on forever. These coordinate grids, these quadrants, they can go on forever and ever and ever. It's almost like they're imaginary and they have no stopping point. Okay, so we've done number 1 where it says to label the x-axis. So I'm just going to exit out because I know that I did that. The second part says to label the y-axis. So right there, ooh, it's hard to tell on this thing. Right here it says to label the y-axis. So again, your y-axis is going to be the one that's running up and down. Okay, and again, I'm going to put a little arrow just to show again that that y-axis can go on forever and ever. So here we have our y-axis, and then down here we have our x-axis. So I've done number 1 and number 2. My next step is to label the origin. So if you remember back at the rules, or the vocabulary I should say, the origin was our starting point. It's the corner where my x-axis and my y-axis, x-axis and y-axis are going to intersect. They're going to cross. That's what intersect means, to cross each other. So where will these two lines intersect? So we have this line going this way and our y-axis going this way. So right here is where my origin is going to be, right in the corner. Okay, and I'm just going to draw a big dot to show that that's where my origin is at. And I'm also going to label it origin. Origin is spelled O-R-I-G-I-N. And also I want to put in the numbers that match with my origin. My origin is always at 0, 0. And we talked about how when you're writing an ordered pair, you always want to put parentheses around the numbers and then a comma in between them. So when I write this, I'm going to write open parentheses, 0, comma, 0, and then close the parentheses. So just like that. That's where my origin is at. This dot represents a 0. It's a circle. To help you remember, it is a 0. 0, 0. Okay? So that is my origin. The next one, number 4, says to label the point 2, 6. Okay? The first number is a 2. The second number is a 6. So that first 2 represents how far I'm going to go along my x-axis. So if this is my... I'm trying to see what... Either way, I'm going along my x-axis going this way. So always starting at my origin, I want to go... Oh, you know what we should do first? We should put our numbers in, huh? So along here, I'm going to put in my numbers. So 1, 2, 3, 4, all the way down at each line. 4, 5, 6, 7, 8, 9, and then the last one makes 10. So right there. As you can see, along the bottom, I went all the way from 1 to 10. I didn't start with 0 right here because my origin is already at 0 right there. And then I'm going to do the same thing going on my y-axis as well. I don't start with 0, I start with 1. Okay, so I did the same thing going along my y-axis again. If this is 0, then 1 must be going up. I'm not going to start my 1 up here because that's not where 0 is at. 0 is down here, so 0 going up is 1, 2, 3, all the way to 10. All right, so again, we want to show the coordinate pair 2, 6. So I'm going to draw that out. Well, let me label it so you can understand. So we have the ordered pair 2, 6. So that's number, what is it? Number 4, right? Okay. So this first number here represents the number that's going to go along your x-axis. So I'm going to put an x on top. And then the second number represents the number that's going to go up 6. So that's going to be on your y-axis. Okay? This is just a visual reminder to tell you, remember, the first number is always going to go along your x-axis. And your second number is always going to go up your y-axis. Okay? So we're looking for the point 2, 6. And again, like I've said a million times already, we start at the origin. Okay, so my first number was a 2, so I'm going to go in 2. And then my second number was a 6, so I'm going to go up 1, 2, 3, 4, 5, and 6. So I'm going to put a point right there. Okay. So when I put that point right there, I also want to label it with the letter. So I believe that was letter A. Okay. So we should have that. Oh, let me see if I can get you to see it a little bit better. Just like that. Okay. And that is at 2, 6. Got it? Okay. The next one I want to do is I want to skip down. Now let's go ahead and do B. Because what I did was on number 4 I put 2, 6, and then on number 5 I did 6, 2, so that you can see the difference. Yes, they're the same digits, but they're in different positions. Now the first one number is always for your x-axis, and the second number is always for your y-axis, the one going up and down. And you have to understand that where they are on the ordered pair within the parentheses does make a difference. So let's go ahead and do number 5, which was 6, 2. The one we just did was 2, 6. Now we're doing 6, 2. So they're not going to be in the same place. Even though they're the same numbers, they're not in the same place. So again, my first number is 6. And let me do this again over here so that you can understand. Okay, so these are two opposite ordered pairs. Now, again, the first number is always going to be on my x. And the second number is always going to be on my y. So again, they have switched positions here. So I want to go in 6 on my x-axis and then up 2 on my y-axis. Okay, so as usual, we start at our origin. I want to go in 6. 1, 2, 3, 4, 5, and 6. And then I'm going to go up 2, 1, 2. So I'm going to put a dot right there, and I'm going to label it B. So, yes, these two ordered pairs do have the same digits. However, they're in different positions. So it does make a difference where they are on the grid. As you can clearly see, those are two different places on the grid. So it does make a difference. Okay, I'm going to skip down to number 7. And I'm a liar. 10 and 11. Okay, you'll notice number 10 is for the letter G. And it is ordered pair 0, 7. 0, 7. Again, we're working on number 10, and that's at 0, 7. So right now you should be seeing number 10. That's what it looks like. We know that the first number is along our x-axis, and the second number is along our y-axis. Okay. So again, this tells me that I'm going to go in 0. So if I'm going in 0, if I'm at my origin, am I really moving at all? I'm not. I can't move 0. I can move 1, 2, 3, 4, 5, 6, and all the way to 10, but I cannot move 0. So along my x-axis, I'm going to stay at the origin. I cannot move any farther, but I can go up 7. So let me show you what that looks like. So again, this is number 10, letter G. So if I want to move along my x-axis, I can't because my first number is a 0, so I have to stay at the 0. And then I'm going to go up the 7. So 1, 2, 3, 4, 5, 6, 7. So again, I didn't move this way at all, so my point must be here at 0, 7. Okay, that's the point 0, 7. And that was letter, what do we say? G. So that was number 10. Okay, and I'm just going to mark it out that I did it. Okay, so again, my first number was a 0, so I'm not moving this way, but my second number was a 7, so I do move up. Okay, let's look at number 11. Again, those numbers are switching spots, which means they are, again, not going to be in the same position. So instead of 0, 7, now we have 7, 0, like this. Okay. My first number is going to be on my x-axis, and my second number is going to be on my y-axis. So just like that. So in this case, we are going to be moving on our x-axis, but we are not going to be moving along our, that looks like a V, doesn't it? There. So we are going to be moving along our x-axis, but we will not be moving on our y-axis because I cannot move 0. It's like saying I'm going to go 0 miles per hour. If I'm going 0 miles per hour, am I moving at all? No. The answer to that is no. Okay. So again, we're going to go 7 this way, but we're not going to go up. Okay? As usual, where are we starting? You should be saying origin. Origin is where we start. So right here. So I'm going to go in 7. 1, 2, 3, 4, 5, 6, 7. And then my y is 0, which means I cannot go up from where I'm at. So my point is going to be right here. Let me switch pins. And that was point H. That's number 11 and point H. Okay? So like I said, 0, 7, in 0, up 7 is very different from in 7, up 0. These are two opposite points on the grid. Okay? You have to understand that. These are two opposite points on the grid. If the numbers are in different positions, it does make a difference about where they are at on the grid. Okay? Your job is to finish filling in all the rest of the points, B, C, D, E, F, and I, and then you'll be done with that one. Just please make sure your name is at the top and put that in the basket, and that is it for that one, I believe. You do need to know that vocabulary. I'm not going to go in depth with this lesson, because it's usually pretty easy for kids to pick it up. Okay, we might have one more day where I go over it, but typically the kiddos in the past have gotten it pretty quickly, so I'm not going to go too much more in depth with it. But I do want to go over this pink one that I gave you, because this is review again, the dividing fractions, dividing a whole number by a fraction, and dividing a fraction by a whole number. I know it can be difficult for some people to grasp, so I just want to make sure that you guys are understanding, okay? As usual, I did 4 on one side and then 4 on the other. You have to have work. You have to have something. No work, no credit, and that goes for both sides. So, and do your work in this, in this space here, in the blank space. If you don't do your work in the blank space, just please do it there. It's a lot easier for my eyes to see if you actually did the work or not, because if I'm looking over here, sometimes it's hard to tell. And please don't forget to pick an answer. I don't know what's going on with some kiddos lately in this group, but lately some people have just been forgetting to pick an answer, and how am I supposed to know what you chose? And as usual, no work, no credit. Guys, you have to show me what your thinking is. If I can't see what you're thinking, then it's really hard for me to go back and help you fix it. Okay? And as usual, you have to ask the questions. I know a lot of y'all have been getting a lot better about asking questions, but it has to get even more so now that we're getting closer to testing. We're officially 2 weeks away from benchmark 2 and only about 40 days away from STAR. So I know, again, that still sounds like a lot, but last week it was already 50 days. You know what I mean? So those days, they count down really, really fast. And every day that you're not here is a big deal. So I want to look at I'm looking at the side that has, that says 3J, page 6, and I'm looking right here at number 1. Okay, so what I did was I went ahead and I just enlarged this model on my paper, and the question does say, look at the model below, the model represents. So you just have to find out which equation matches the model. So let's look at that model, and mine's just kind of a rough picture of what you have on your whole paper. On your paper. I just made it a little bit bigger. So this right here tells me that all the way from here to here equals 4 holes. Okay? We have 4 holes. Okay? And clearly this 4 holes has been broken up into several pieces. It's been broken up into 4 parts, and each one of those 4 parts is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So this is very similar to a number line that goes from 0, 1, 2, 3, and 4. This is the same exact thing. So all I would do is I would make 4 spaces here. And again, 3 lines will give me the 4 spaces between each number. Okay? So if I count, I should have I believe 16. So starting at my 0, that would be 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I hope I'm doing this right because it's hard for me to tell from the back. 8, 9, 10, 11, 12, 13, 14, 15, and 16. And then if I count here, that should also give me 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So if I look at my answer choices, first of all, we know that that 4 got cut up into 16 pieces. If I'm cutting something or it's breaking apart, it's getting smaller, we automatically know that our operation is division. And that gets rid of answer choices A and B, because on A it says 4 divided by 1/4 equals 4, and then on B it says 4 times 1/4 equals 16. Okay, well, first of all, 4 times 1/4 cannot equal 16, because if you remember, and you need to, okay, because some people are still making this mistake on the quiz, 4 times 1/4 cannot equal 16, because I have to multiply my whole number times my numerator. So this would give me 4 over 4, and then 4 divided by 4 would have to equal 1. So there's no possible way this could be multiplication. No way. Okay, so that 4 did get broken up into 1/4 pieces, and it ended up giving them 16 pieces. So the answer for this one would be C. And I still want to see you show the work for answer choice C. So when you're showing your work, the equation is 4 divided by 1/4. So we know that if we start with a whole number, we should end with a whole number. So what's going to happen is we're going to change our sign to multiplication, and we're going to flip our fraction. Again, when I start with a whole number, I want to change the sign and flip the fraction. Let me show you something that people have been doing, and it's the wrong process. You're trying to do the same thing for every single one, and it's not the same thing. It's a difference when the whole number comes first and when the fraction comes first, and you have to know the difference. So some of you are doing this. You were saying that you had to do 1/4 times 1/4. Okay, if I have this, it's going to give me this right here is going to give me a fraction as an answer. So that cannot possibly be the way to do this problem. That's the incorrect process. You'll notice that on a lot of your work right now, I've been putting incorrect process, because it's not the way that you do it. Again, if you start with a whole number, you need to end with a whole number. And this right here is going to end up with a fraction. So it cannot possibly be the way. So I'm going to X that out. So the correct process from here should have been 4 times, and then you want to do the reciprocal, flip the fraction. Again, reciprocal means to flip. 4 over 1. Okay, and then from here you want to multiply the 4 times the 4. And that's going to give me 16, and our denominator is going to stay at 1. And then we talked about how if I divide 16 by 1, it's still going to stay at 16. So you have to show me this work. Even if you can see what the model is, I still want to see the work on the side. Okay, that was number 1 on side 3J, page 6. Again, if you're going to do this and you're starting with the whole number, you need to understand that is the wrong process, and it's going to give you the wrong answer. Okay, moving on. On the other side, if you'll flip it over on page 3J, on 3J page 5, I'm looking at number 3, because at first it does look kind of like wild and stuff. So at first it has a 1 whole. So all it's saying is you're starting out with 1 whole, and that 1 whole is getting cut up into thirds, and that third is getting cut up into 18ths. So what I did here was I did that same thing, but I just made it a little bit bigger. Okay, this 1 whole doesn't necessarily matter. All they're saying is this 1/3 came from this 1 whole. So we don't have to worry about the 1 whole. But we do need to understand that this 1/3 did get cut up into so many pieces. So if I look at this 1/3, this line, these lines match up to each other. Okay, so how many spaces do we have here between from here and here? We have 1, 2, 3, 4, 5, and 6. So that's going to tell me what this 1/3 is going to be cut up into. Okay, so what's happening here is we have that 1/3 cut up into 16 pieces. Sorry, cut up into 6 pieces, not 16, my bad. Okay. So the process here again is if we started with a fraction, we want to end with a fraction. So the only way to make that happen is if I also turn that 6 into a fraction. So I'm going to have 1/3. And again, always change your sign from division to multiplication. So division is going to change to multiplication, and that 6 is going to become 1/6. And then from here, we just can multiply our numerator times our numerator and our denominator times our denominator. So 1 times 1 we know is 1, and 3 times 6 is 18. Just like that. So that's how we know, or that's where they get this 18 from. Because if you count all the spaces here, this is just 1 out of 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay? The rest is up to you. Do your best to finish the rest of the questions in class. The coordinate grid one should definitely get done. It's not going to take you that long. Should take you, I don't know, maybe tops 10 minutes, even if that, and you only have a few more left to do. I did a lot with you. If you finish your fast focus, which is the one we just went over with the dividing fractions, then you need to finish your dividing fractions essay on Google Classroom. And if you haven't done your multiplication tables, those are due next. Sorry guys, I got cut off at the very end. I just wanted to let you know to finish your Google Classroom essay and that your multiplication tables are due Friday as well. So make sure those are done because I am going to pick those up at the beginning of class. Also remember that your homework is not the same as what's on the back board. It's the next 2 pages of your daily teaks. And just make sure all your work is done. Okay? Peace, people. Have a great day.